Welcome to BinMaster. We're a leader in level sensors and bulk management inventory software. You may have no idea what that means, what level sensors are, what level sensors even do. I'm Colin Humphrey, engineering manager, and I'm here to fill you in on what that means and hopefully inspire you to join us for your senior design capstone. Last year, BinMaster took a direct hit from an F3 tornado. While no one was seriously hurt, our manufacturing facility was completely and totally disabled and considered a total loss. Fast forward a year, and we are totally rebuilt, essentially from scratch. Our offices are located right here at Innovation Campus, and our manufacturing facility is at 33rd and Superior and humming along every day. BinMaster is unquestionably stronger than it was when it was first hit by that tornado. BinMaster's first sensor was developed in the mid-1960s when a local farmer approached Garner Industries to design a switch to prevent overfilling in grain silos. That switch was the diaphragm switch, which we still sell to this day. Over the years, our product offerings have greatly expanded. We are the leading manufacturer of point level and continuous level sensors. These are used by thousands to monitor the level of bulk, solids, and liquids in bins, tanks, silos, and hoppers. We also offer a industry-leading inventory management software called BinCloud. This makes inventory management in conjunction with our sensors very easy. You can even use this tool from a PC, tablet, or smartphone. We own that software, we modify it to fit what the industry wants. It is our software written for our customers. In the bulk solids world, solids don't always behave the way that you want them to. They don't sit in the tank completely flat and provide you an accurate estimate with a single point of data. Often you have steep angles of repose, rat holes, and things like that that cause a complex topography that make a continuous single point measurement somewhat inaccurate. So that's where a 3D radar comes in. So I've got a radar here. It's a BinMaster CNCR190. It provides a very narrow beam that returns a distance. Then given the geometry of the bin, we can estimate total volume. However, in many cases, a more rich data set is needed to accurately estimate the volume of that bin. The product that BinMaster is currently developing is an approach where we take a radar, not unlike this, and we will articulate it, pointing it around a bin like so, and collect not just one data point, one distance, but multiple. This will allow us to create a point cloud, which will then be used to generate a volume and a visual representation, which is where you come in. This project is a data pipeline from our articulable sensor to our cloud platform, BinCloud. There are two phases in this project. The first is to estimate volume based on that point cloud, and the second would be to generate a visual representation of that volume. So we currently do this with our 3D scanner, but unfortunately we don't own the source code to that program. And as we go into a new platform, it would make sense for us to develop and own our own visualization software. And so that's what you're charged with. Some details on that. There will be two types of scans that we'll do. There'll be something called a light scan and a full scan. So a full scan is exactly what I described, right? Taking a lot of points, that will produce a rich data set with many points that will be fairly easy to estimate a volume and a surface from. A light scan will involve maybe a few points. The reason for this is simply that it takes a long time to physically move the radar. So by enabling a light scan mode, we leverage just taking a few points against previous rich scans, which will allow us to estimate how the volume has changed without a full scan of the surface. Ideally, you would be able to interpolate between the light scan and the full scan, and that'll be part of the project. The problem is well defined. We're going to give you a point cloud, a series of XYZ data points, and you will turn that into a volume estimation and a visual surface. The approach is very open-ended. This could be potentially an opportunity to use leverage tools like machine learning or AI. However, you don't have to take those approaches, and we're open to any number of ideas. So if that's the kind of project that interests you, this is going to be a good one for you. We plan on, for starters, to meet weekly on the phone and then monthly in person here in Innovation Campus. It'll be a pretty easy project for us to communicate on, just given our physical proximity to the university. I've worked on senior projects where that wasn't easy. This will be an advantage. One of the reasons BinMaster sensors exist is to keep people safe. There are a lot of hazards working in high environments like the tops of bins and silos. From just falling to getting engulfed in the material inside a silo, or even structural failures of the silo. Our sensors are more convenient, they provide real-time data, and they're often more accurate than manual measuring with a measuring tape, also reducing the risk of regulatory non-compliance. Since 2009, Bin Master's had the exclusive rights to this 3D scanner technology I'm holding right now. This works by sending out essentially a chirp, an audible chirp that you can hear from each of these horns, slightly different each time. Then the same horns act as the ears and pick the signal back up and process it, giving a topographical picture of the material below the scanner. They're highly accurate in comparison to a single point scanner like this, where you get one point of data that essentially just tells you how high is the material up in the bin at that specific point. In an application where accuracy is paramount, a 3D scanner will provide a more accurate volume estimation than a single point will. The 3D scanner is best suited for large silos with material that doesn't want to sit flat. When material goes into a bin, let's say from the center, it creates like a hill. We call that the angle of repose. Now, certain materials have a more aggressive angle of repose. Certain bins have multiple entry points or multiple exit points, which creates a complex topography. Additionally, you can have materials that stick together in a particularly challenging way that create what we would call a rat hole, a deep hole that doesn't relax itself naturally. Any of these factors make a 3D scanner, or a 3D radar as we're discussing, an ideal candidate to replace a standard continuous single point radar. Currently, our 3D scanner option does come with a software package that allows you to visualize the material inside the bin. This is valuable for a number of reasons, obviously, in addition to accuracy, but also in certain applications, the orientation of the material in the bin matters as well. 3D scanners give you that information. Unfortunately, since we purchased this technology, this 3D scanner, and the software that interprets it, we can't make any changes or updates, which is part of the reason we're working on this 3D radar project. So when is a 3D level scanner or a 3D radar applicable? 3D scanners and 3D radars really shine in applications where high accuracy is required, but a load cell isn't appropriate. So think like massive silos, for example, like in the agriculture industry with corn or grain or whatever. You might have like 100, 150, 200-foot silo that weighs hundreds of thousands of tons. So some industries where a 3D scanner or 3D radar would be applicable, anything where there's a large bin and a cakey material that doesn't want to sit flat. So think like agriculture, feed and livestock, cement, mining applications is a big one, plastics, chemicals, power generation, and then of course, food processing. So we chose radar because radar is a very mature technology at this stage. In the 80 gigahertz range that we're using it, radar can cut right through like steam and dust and things like that. Not to mention radars are a very low maintenance platform. The decision kind of made itself. It's the best of all worlds, and it excels in the areas that we need it to excel. Our existing 3D scanner, while it works really, really well, relies on acoustic signals. Additionally, there are intrinsic limitations to that acoustic software, like for example, corrugated walls of certain types of bins will scatter the sound and make a measurement impossible. Whereas radar really doesn't care what's around it. If you can get the beam angle nice and narrow, you can completely ignore corrugated walls and things like that. So what's it like to work at Bin Master? Well, aside from the occasional tornado, it's pretty good. Particularly the corporate culture is excellent. I can walk right into the president's office whenever I need to and bend his ear about whatever's on my mind. Same thing goes for my boss, the executive vice president. He doesn't even have an office. You can walk right up to his desk and we always get the time of day. So it's a great place to work. On this project, you'll work with me, and then more on the server side, cloud side, you'll work with Adam Mayo, our senior technology officer. Between the two of us, we'll help you through the details of the project and make sure you're accomplishing what we need. Bin Master is growing and growing quickly. Despite the fact that we were hit by a tornado a little over a year ago, we are up and running. In fact, we are beating sales numbers from last year, month over month, year over year. Since that tornado in April, we've actually made 2 acquisitions. We've purchased other companies. So Bin Master is in a very strong position in the market and expanding and constantly pushing the envelope in R&D and what we can offer our customers. I'm Colin Humphrey, engineering manager here at Bin Master. Thank you for your time in listening to our pitch video, and I hope you decide to work with us on your senior design capstone.